Good morning and good afternoon, ladies and gentlemen, depending on where you are located around the world. My name is Mircea Gradu. I'm the Senior Vice President for Product and Quality at Velodyne LiDAR. And I will talk today about the pedestrian safety-focused, highly innovative ADAS perception solutions developed by Velodyne and some of the aspects related to their validation and testing. I would like to start, though, by thanking the organizers of this event and all the participants for keeping it alive despite the coronavirus restrictions. And certainly I hope to see you again live next year. The agenda of my presentation includes a brief company introduction. I will talk about the ADAS LiDAR-centric hardware and software solutions developed at Velodyne, our safety initiative, and then certainly we will emphasize aspects related to the PAEB solution and its validation, and we'll conclude with a proposal for standardized low light conditions. The history of our company began in 1983, where our current chairman of the board, David Hall, founded as an acoustics company. In 2004, David completed successfully in the DARPA Grand Challenge. And shortly after, in 2005, invented the real-time 3D LiDAR. Our company began the first commercial production of the real-time 3D LiDAR in 2007. We are represented all around the world with an advanced research center in Alameda, California, a global headquarters and manufacturing also in the Bay Area in San Jose, California, and we have teams in Rüsselsheim, Germany, and also in Beijing, China, to serve the EMEA and the APAC markets. We foster partnerships with very reputable manufacturing companies, tier ones in the automotive space, but also other industries, including Velodyne and Nikon. And our main goal is to optimize the cost and certainly take advantage of the global supply chains while maintaining the highest possible quality for our product. Our product offering includes 360 field of view sensors. Shown on the left side is the Alpha Prime, the flagship of our product for autonomous vehicles. And on the right side, the Velodyne product family, which is extremely suitable for ADAS applications, but also for many others. The adoption of our product occurs in multiple industries. Beyond the automotive and mobility industries, we see a lot of interest in public utility, unmanned aerial vehicles, drones, security, industrial and agricultural, defense, last mile delivery, smart cities, and certainly others. Coming back to the Velodyne family, as I mentioned, it is a sensor we optimize specifically for ADAS applications with a very long range. And the idea was to make it also embeddable and customizable for various requirements. The field of view resolution and line count options can be offered currently based on our innovative ASIC solution, the micro LiDAR array architecture, and we meet the automotive grade temperature and reliability requirements along with functional safety, ASIL-B level, advanced diagnosis, and PDP time synchronization. We also addressed sensor-to-sensor interference mitigation, and certainly the, as I mentioned before, the flexible vehicle integration at various locations around the vehicle, including at the windscreen, behind the rear view mirror, in the bumper, radiator grille, wherever the OEM finds an optimum location for the sensor. In order to address that, we also have a vehicle integration or vehicle interface module. Another product extremely suitable for ADAS applications is the Velobit family, which we announced at the CES event. with a very compact size, will range up to 100 meters, a field of view which will be optimized further for the ADAS applications based on specific use cases, and with the ability to be configured for a very wide range of applications. In case of the automotive or vehicle applications, multiple Velobits can be stacked to fit the customer use cases and needs. And certainly based on the very compact size, it also offers a very good embeddability in the vehicle styling, in the vehicle overall structure. Vela is our software solution, which complements very well the hardware solutions, which I talked about. It has the ability for obstacle detection and tracking, lidar-only object recognition, static and dynamic object segmentation, dynamic object motion prediction and collision mitigation, real-time SLAM for ego motion estimation, feature harvesting for automated high-definition mapping, real-time map-based localization, and cloud infrastructure for remote polling and data upload. I'll talk briefly about our safety initiative, which continued over years with very strong outreach to the organizations that are playing a significant role in regulations. In particular in the US, that includes the senators and House of Representatives, the Department of Transportation, National Highway Traffic and Safety Administration, National Transportation Safety Board, IIHS, Consumer Union, and many others. A specific initiative, which is now in its third edition, as a virtual event this year, is the World Safety Summit. We had a very good speaker lineup, including Mark Rosekind, the former NHTSA administrator and currently the Chief Safety Innovation Officer at Zoox, and many others. Certainly, we hope to see you in person at the next one in 2021. Our safety initiative includes a SOTIF-oriented ADAS rating system. In this slide, I'm showing just the automatic emergency braking and automatic emergency steering functionality being assessed. On the left side, in the gray column, you can see various criteria, various performance criteria for the ADAS function. And that includes certainly the light and weather performance. Again, very similar to the approach that SOTIF ISO 21448 takes for the assessment of vehicle systems. As a resultant of the assessment presented before, and focusing on the main functions of ADAS, which are the lane keep assist, automatic emergency braking, adaptive cruise control, and blind spot warning, we developed a label which mirrors to a certain extent the crashworthiness label used by NHTSA, and we hope to progress in terms of implementing this with a clear goal to not only enhance the safety of the ADAS system, but also explain and educate the end user, essentially the vehicle owners, regarding the capability of the real, true capability of their vehicle. A bit of detail on our Vela solution and the way we tested and assessed its capability. If you just look at the current performance of radar-based AEB systems, radar and camera-based, it's very interesting to note that even some of the dealerships, which are certainly guided by the OEM in the way they promote and sell the vehicles equipped with this type of functionality, they highlight the limitations. And the limitations of radar-based AEB systems include things like objects or pedestrians on the road, vehicles in your lane, oncoming vehicles, intense weather situations, obstructed radar due to dirt and debris, So a variety of conditions that occur very frequently in normal operation, under normal operation. On the other hand, with the lidar approach, we can mitigate very well the low light conditions, and certainly I will show the test results supporting the statements. Objects blending with the background, shadowy conditions, and we also perform a real-time distance measurement. Talking about this topic at the LiDAR conferences certainly is preaching to the choir, but I would like though to emphasize the difference we noticed between an automotive grade 2D camera and the performance of a Velodyne 3D LiDAR sensor in low light conditions. As you all know, the cameras are hampered at night and cannot provide enough accurate information, as shown on the left side. The radar doesn't have enough resolution to capture all the required data for the perception algorithms, and then the LiDAR excels in these conditions because it has its own light source and it's not affected by complete darkness or daylight. The results that we acquired during this testing are summarized in this table, which is designed in compliance with other NHTSA testing performed in the past. And it includes various overlap between the vehicle frontal area and the adult dummy, which was used in the testing. And the interesting thing is to see that we managed with the combination between our Vela software and the Velarray sensor to obtain very good results with green in all these categories. For comparison, you can see a radar and camera-based PAEB system under the same exact conditions, and some of those were resulting into collision, shown in red. And certainly that's something extremely concerning. We observed live the impact as shown on the bottom of the pictures in the pictures on the bottom of the slide. On the left side, camera and radar resulted in collision with the dummy, and LiDAR in conjunction with our Vela system resulted consistently into maintaining a safe distance to target around 1 meter. That's what we show on the graph on the right side. The LiDAR equipped system stopped 1 meter from the pedestrian target in a very consistent manner. Speaking about the Vela software system, the segmentation of the data layers is shown in this slide. The region of interest, the dynamic object, collision prediction, the trajectory of the ego vehicle is defined, static objects are captured, and certainly the ego vehicle and its motion. We used the combination between the Vela and Velarray on several scenarios which are extremely relevant for the functionality not only of the PAEB but certainly any safety system on the vehicle. Potential bicycle collision on unprotected right turn. You can see that the system detected the hazard and it made a decision to stop the vehicle safely and resumed the operation afterwards after the bicyclist shown on the left side was actually passing through the intersection. Similar approach on a scenario where an elderly person falls from the sidewalk into the vehicle path. Another scenario with a child emerging from behind the vehicle, behind the parked vehicle. And another scenario with an oncoming vehicle blowing the red light during an unprotected turn. As a resultant of this test evaluation that we conducted, we would like to continue to promote our very strong suggestion and proposal for standardizing the low light conditions for PAEB testing. And another set of factors supporting this is the data relate to the pedestrians dying in motor vehicle crashes in 2018, which is a very high number at 6,200. A significant increase of 53% since 2009, and 17% of all crash fatalities being pedestrians. If we dissect the data deeper and we look at the dark versus daylight split in terms of the operating conditions for this pedestrian fatalities, you can see that in 2018, there is a very significant amount of those attributed to dark conditions. So fatal pedestrian crashes occurring in dark conditions are at 76% in 2018, to 2,100 in dark, not lighted conditions versus 1,256 in daylight conditions. Certainly, we are not the only ones observing this and trying to take action in support of expanding the testing and validation of the PAEB systems. The American Automobile Association, IEEE, is recommending clearly that the nighttime conditions would be significantly, the functionality of the PAEB systems would be significantly enhanced if a mean to detect better in dark conditions, detect obstacles, targets in dark conditions would be implemented. So the evaluation of their current evaluation of the pedestrian detection systems is showing this ineffective assessment. NHTSA conducted also very extensive testing starting as early as 2017. They showed in this type of slides, they summarized the results under different overlap between the pedestrian and the vehicle frontal area. This is a very telling slide because what it shows is the ratio between no impact tests and the number of test conditions is not one. In other words, you see that many tests resulted in impact, so the no impact test number is smaller than the overall number of test conditions. Ideally, you should have green all over the slide in terms of this ratio, and you can see that there is a significant difference, especially in night conditions. In fact, that's the message clearly shown by the slides, that night conditions, as you can see both on the upper and lower side, are resulting in significant number of impacts, less than the suitable ratio of 1 between no impact tests and the number of tests conducted. Same type of evaluation, this time with a different vehicle overlap and a different pedestrian speed. You can see that they also assessed a stationary pedestrian versus a moving pedestrian at, with 5 km/h speed of the pedestrian, but again, the same theme in terms of the results, especially under night conditions. You can see that the ratio between no impact test versus test conducted is less than the desirable one of 1. To summarize our position and our recommendation, if you look at the total spectrum of conditions that are currently used in overall vehicle evaluation, you can see that based on the prior approaches by NCAP, all the test conditions are above 1 lux ambient illumination, and we would strongly suggest the expanding the ambient illumination for under 1 lux in order to capture those very critical dark, not lighted conditions. I hope certainly the results were telling, and I hope both the performance of our system and the recommendation that we're making resonate well with you, and looking forward to feedback and discussions during the Q&A session. Thank you very much.